Hi there, welcome back. Can you find the values of x and y in this equation? There's a number of different ways of doing this, but I particularly like this approach. Okay, the first thing to notice is that all these numbers, 72, 48 and 6, are all divisible by 6. I'm therefore going to rewrite this in terms of 6. So 72 is actually 6 squared, which is 36, multiplied by 2. And that's all raised to the power of x. And 48 is 6 multiplied by 8, all raised to the power of y. And this, of course, is just 6 to the power of x times y. Now, if we utilise the fact that if we've got a number raised to a power, and that's multiplied by a different number raised to the same power, then this equals those two numbers multiplied together, all raised to that power. Then we can rewrite this as 6 squared, all raised to the power of x, multiplied by 2 to the power of x. And we have 6 to the power of y, multiplied by 8 to the power of y. And this all equals 6 to the power of xy still. Next we can use a rule that says if we've got a number raised to a power and that's all raised to another power, then we can rewrite that as that same number raised to those powers multiplied together. And now applying that to 6 squared to the power of x, we get 6 to the power of 2x multiplied by 2 to the x, 6 to the y, 8 to the y, all equals 6 to the xy. And now we can group these 6's together, and we can also group 2's together. So you've got 2 here, and 8 is just 2 to the power of 3. So let's first rewrite this. So we've got 6 to the 2x multiplied by 6 to the y, and we've got 2 to the x multiplied by 2 to the power of 3, all raised to the power of y. And this equals 6 to the power of xy. And if we again use this rule, we end up with 6 to the power of 2x, 6 to the power of y, 2 to the power of x, and 2 to the power of 3 multiplied by y equals 6xy. We're now going to use the rule that says if we've got a number raised to a power and that's multiplied by the same number raised to a different power, then that equals that same number raised to those powers added together. So we have 6 to the power of 2x plus y multiplied by 2 to the power of x plus 3y. And this still equals 6 to the power of xy. And now you'll notice that both sides are beginning to look similar in format. In fact, if we put a 2 here, 2 to the power of 0, and 2 to the 0 is of course 1, so this has no overall effect, then the format is very similar because we've got a base of 6 here and a base of 6 here multiplied by a base of 2 here and a base of 2 here. And if we say that equal bases mean equal powers, then we can write down the following two equations. 2x plus y must equal xy. And x plus 3y must equal 0. And now we have a pair of fairly simple simultaneous equations. If x plus 3y equals 0, then x must equal negative 3y. And if we now substitute that into this first equation here, we get that 2 lots of negative 3y plus y equals negative 3y multiplied by y, which means that 3y squared minus 5y must equal 0. And factorising, we get that y multiplied by 3y minus 5 must equal 0, which means that y must equal 0, or y must equal 5 over 3. And substituting these back into one of the equations above, this means that x must equal 0, or x must equal negative 5. And they are our answers. Did you get it? I hope so. And if you like questions like this, check out a few of my other videos. Okay, that's it. See you next time. Bye.